So today we're going to look at the double angle formulas. So they are right underneath the formulas that we looked at yesterday. And so when I'm talking or referring to the formulas, these are the formulas we're looking at, okay? All right, find the exact value. Well, we know how to find the exact value of cosine. Cosine is adjacent over hypotenuse. So the cosine is 12 over 13. We've been doing that forever, right? Tangent is TOA, so opposite over adjacent. But now, what happens when I asked you to find the sine of 2 theta? Now, a lot of you think, oh, we would just double sine, right? So we would take opposite over hypotenuse and double it. But we don't. This is where we're going to start using the double angle formulas. So if you look at our formula sheet, the double angle of sine is 2 times the sine of u cosine of u. So I'm going to use 2 times the sine of u cosine of u. And now I'm going to refer back to our triangle. 2 times the sine is opposite over hypotenuse times the cosine, which is adjacent over hypotenuse. And this is like having 2 over 1. And now we just multiply straight across. 2 times 5 is 10, times 12 is 120, over 13 times 13 times 1, which is 169. It cannot be reduced, so that is the sine. All right, let's find the cosine double angle. So again, I'm going to refer back to my formula. But if you look, cosine has quite a few options. You can use cosine squared of u minus sine squared of u. You can use 2 times the cosine of u minus 1. And you can use 1 minus 2 sine squared of u. It's basically what you have available to you. Because I have a full triangle, I can find cosine and sine. It's not that big of a deal. So I'm going to choose to use this first one because I know both sine and cosine already. So the cosine is cosine squared of u minus sine squared of u. Again, I could pick any of those, but because I have this triangle and I know sine and cosine, I'm just going to pick this one. So I am going to take cosine, which is adjacent over hypotenuse, and square it, minus sine, which is opposite over hypotenuse, and square it. Now, according to our order of operations, we have to square first. So 12 squared is 144, 13 squared is 169, minus 5 squared, which is 25, and 13 squared again is 169. Common denominator of 169, and when I subtract the 2, we have 119 169. Okay, so that's pretty easy when we're talking about the double angle formula. Okay, all right, let's try something a little different. Find x when we are working between 0 and 2 pi. This is our domain. So we're solving equations back again. But this time, we're going to have double angles in our equations. So this time, we're going to use identities to swap out to help us solve. So whenever I see a double angle, I'm going to replace it with the formula. And we learned that the double angle is the same as 2 sine of u cosine of u. So I'm going to replace the double angle with 2 sine of x cosine of x. So we're just using it as another form of an identity switch and helping us to solve our equations. All right, when I look at these two terms, is there anything that they both have in common that I can factor out? Well, I can factor out a sine. So when I take sine of x out, I'm left with this. And now I have the, sorry, Sam just walked through. Now I have zero product property, where the sine of x equals 0 and the 2 cosine of x minus 1 equals 0, and we can solve these equations. When is sine equal to 0? Sine is equal to 0 at 2 pi or 0 pi and also at pi. Cosine, if I add 1 and divide both sides by 2, when is cosine equal to 1/2? Remember, cosine is your x value, so at pi over 3, and it is also at 5 pi over 3. So x equals 0 pi plus pi n, because they are diagonals on the unit circle or half a pi away. But here x equals 1/3 pi plus 2 pi n, and x equals 5 pi over 3 plus 2 pi n, because they are not directly across from each other on the unit circle. Okay? I have one more example, actually 2 more examples to go through with you really quick. Use the product to sum formula. And again, this product to sum formula is found on your sheet. The product to sum formula is down here. And so now we're going to use this, or sum to product. So we have to decide which one of these two now that we are going to look at. So if you look at this example here, where the cosine of 50 degrees times the cosine of 20 degrees. Well, am I going from multiplication to addition or addition to multiplication? This is product to sum. So we're going to use the product to sum formula. It's cosine times cosine. So I'm going to use this formula right here. This is my u and this is my v. So it says to take 1/2 times the cosine of u minus v plus the cosine of u plus v. Okay, so now we have 1/2 times the cosine of 30 plus the cosine of 70. Well, I know that the cosine of 30 is on my unit circle. The cosine at 30 degrees is the same as square root 3 over 2. However, cosine of 70 is not on my unit circle. I can distribute 1/2 and I get the square root of 3 over 4 plus the cosine of 70 degrees over 2. And that's how we would leave that. Now, what if we use the sum to product formula? So now, what if I gave you the cosine of 70 degrees plus the cosine of 10 degrees? So now, we're going from a sum to product. So I'm going to use the cosine right here. So it says 2 times the cosine of u plus v divided by 2 times the cosine of u minus v divided by 2. So I have 2 times the cosine of 80 divided by 2, which is 40 degrees, times the cosine of 60 divided by 2, which is 30 degrees. Again, I do not know the cosine of 40 degrees, but I do know the cosine of 30 degrees, and that is the square root of 3 over 2. So now if I multiply these all together, I have a 2 on top and a 2 on the bottom, which cancel, and I'm left with cosine of 40 degrees times the square root of 3, but I'm just going to move that to the front because that would be the proper way of us writing it out. Okay? So if you have any further questions at all, you can let me know. Otherwise, that is the end of this recording.